All right, we are doing section 7.2 today, which should be a very quick section. Should be a section that, especially if you have a calculator close, it's going to help you with the first part of this video or this series of videos. So the lesson we're doing is called the number E, which sounds very strange that I'm saying it's about a number and I'm using a letter. But E is actually a special number. It's called the natural base, or it's often referred to as Euler's number. Euler's was the mathematician that did the work that was involved with this idea of this exponential or this natural base number. And so for that reason, the number was kind of named after him. And his last name started with an E. I know it looks like Euler's, it's actually Euler's. And so when they named the number, they used the letter E to represent it. It's kind of like pi. It's a number that is irrational, meaning you cannot write it as a fraction. It has a decimal equivalent, and I'm going to show you exactly where the button is on your calculator to get it. But it is a decimal of equivalent of about 2.71828, and then it just keeps going and going. We should treat it as a constant, just like we do with pi. I know pi has a symbol attached to it, but it is still a number. It is still a constant. E has a lot of applications in the business world and in the science world, and that's why it's often called a natural base, because there are a lot of things in nature that actually use this Euler's number or this growth number to work with. So first I want to talk calculator. So if you have a calculator close by, grab it because I want to show you where this button is on your calculator. So your E button, let me kind of freeze my screen a second so I can write on it. The E button's down here. It actually has the button that has the LN, but it's the second feature of that button. So to get E on your calculator, you're going to hit second, and then you're going to hit this button that has the LN, and that's going to get E to pop up on your screen. So I'm going to do that now. So I'm going to do second, and then that button, and it'll get E on the screen. And then you just have to input the exponent. So my exponent is 4. You're going to get a ton of decimals for these because of the fact that it is this irrational number to begin with. So when I take it to a power, I'm still going to get another decimal. On Delta Math, I'm going to ask you to go 2 decimal places. So this one's going to round up to 54.60. Oh, this actually, the deck directions here say 3 decimal places, so we'll go that far. 54.598, but on Delta Math, I'm actually only going to have you go 2 decimal places. So the next one, E to the 0.6 power, so again, second, and then that button has the L and the N on it. We're going to type in 0.6. We get 1.822, or 1.82 if we're going 2 places. And then the last one, you're going to have to type in the -3/8 first. So I'm going to type in -3 divided by 8, then hit the second and the button with the LN on it, and then 0.5 for my exponent. And we get -0.618. So it's important to know where the button is, because when we do applications, which is going to be the very end of today's lesson, you're going to need to hit that button multiple times for different formulas we're going to work with. So that is your basic calculator piece. The next piece you actually won't use a calculator for, and there's going to be a set of questions on Delta Math like this as well. Because E is a number, we can treat it the same way we treat any base when it comes to exponent rules. So I'm going to go through, I've got 6 questions here, just a recap of exponent rules. So these are not ones that I want you to use a calculator. I want you to apply the exponent rule that we've learned earlier in this class. So the first one, e to the third times e to the fourth. So our rule is if my bases are being multiplied, I add the exponents. So I get e to the 7th power. So on Delta Math, it will actually say use the appropriate simplification with exponent rules. So I don't want decimals here, just use the rule. For B, first I'm going to divide the 10 divided by 5, which is 2. And then for the e part, since I'm dividing bases, I'm going to subtract exponents. So I get just e to the first, or you could just write e. So you could write it like that, or you could write it as just 2e. For the third one, I'm taking the whole thing and squaring it. So first I have to just square the 3. That is not an exponent rule. That's just 3 squared, which is 9. But my exponent rule comes here. When I'm taking a power to another power, we're going to multiply exponents. So we're going to do -4x times 2, which is -8x. And actually, I can go a step further, because we never want to leave a negative exponent as our answer. If it has a negative exponent, it means it needs to move to the bottom. So my final answer is going to have the 9 is going to stay, and then the e to the 8x is going to move to the denominator. For the first one in the bottom row, I'm going to first cube the 2. So 2 times 2 times 2, or you can use a calculator, it is 8. And then I'm going to multiply my exponents here together, since I'm doing power to a power. So I get e to the 9x. Not going to do anything with the bottom right away, because there was nothing additional in the denominator. I'm going to reduce my fraction. So 8 divided by 6 reduces to 4/3. And then I'm going to subtract my exponent again. So I have both bases are being divided. So I'm going to subtract exponents. I get e to the 8x. And it is positive, so it does not need to move. If you're taking a radical, like a square root or a cube root, you're going to take the root of the number of the coefficient. The square root of 81 is 9. And then to simplify the e's, you're going to do power over root. So that should sound familiar from last chapter. So we have the 6x power, the root is 2. So 6x divided by 2 is 3x. And then finally, the last one, you are going to add exponents since you are multiplying bases. So this is actually very similar to the very first one we did, just a little more involved exponent. So when you add exponents, you're going to add like terms. So I can add the 2x and the 3x together, and I get 5x. And I can add the 5 and the negative 2 together, and I get 3. So as you go through and do delta math, I put kind of a question that's similar to each one here. If you need to come back to this video to help you figure it out, you can do so. Other than that, those are the basics that should take you through the majority of the assignment. We'll have application videos and graphing videos in a second.